This video will show you how to complete page 12 out of your math book. So exercises 9 through 5 says if a student randomly selected a cracker from a large jar, 9, what is your estimate for the probability of selecting a lion? So over here is the table, which I just copied it from the previous page so I wouldn't have to keep flipping back to it. This is all the data that was on the previous page, so this is what I'm going to use as a reference to answer these questions. So with number 9 asking about the probability of selecting a lion, we would represent it like this. And we know that the total, when you add all of these animals together, you would know that it would be 20. Okay, there were 20 animals in that jar, and this is the number of times that these were, there were 2 lions in that 20, 1 camel, 4 monkeys, 5 elephants, 3 zebras, and 3 penguins, and 2 tortoises. And lions, there were 2 out of that 20. Oh, look, it's a fraction that we can simplify and keep it in fractional form. So I'm going to, a number that goes into both 2 and 20 evenly is 2, sorry. So 2 divided by 2 is 1. 20 divided by 2 is 10. Let's go ahead now, since it's simplified as a fraction, let's go ahead and turn it into a decimal. So 1 divided by 10 is 1/10, which is 10% chance of happening. Number 10, what's your estimate for the probability of selecting a monkey? So label it like this, probability of selecting a monkey. There are 4 monkeys represented in this out of the 20. Let's simplify this fraction. So a number that goes into both 4 and 20, one that I can think of right off the top of my head is, well, 2 goes into both, so 4 divided by 2 is 2. 20 divided by 2 is 10. And I can simplify it even further. A number that goes into both 2 and 10 is 2, so 2 divided by 2 is 1. 10 divided by 2 is 5. Some of you might have went from here to here because you would be like, oh, I know 4 goes into both 4 and 20, so divide the numerator by 4, which would equal 1. Divide 20 by 4, which would give you 5. Both ways work. 1 divided by 5 would give me 2/10 as a decimal, which would give me 20% as a percent. 11, what is your estimate for the probability of selecting a penguin or a camel? Okay, I see this word or, and in probability, that means you got to add the probabilities of each. So I need to add the probability of selecting a penguin and add it to the probability of selecting a camel. The probability of selecting a penguin or selecting a camel. Okay, so the probability of selecting a penguin is 3 out of 20. I'm going to keep them as a fraction. I'm not going to turn them into decimals or percents because I'm going to have like denominators, so it'll be pretty easy for me to add these fractions. Or means add camel now. Probability of selecting a camel is 1 out of 20. Okay, look, we have 2 fractions. They already have like denominators, so we're going to maintain that denominator because that's what you do when you add or subtract fractions. But the numerators, you got 3/20 plus 1/20, so that would be 4/20. And this fraction can simplify, let's go ahead and simplify all the way down. Divide by 4, divide by 4 is 1/5, which 1 divided by 5 or 4 divided by 20 would give me 0.2, 2/10 or 20/100, which would be 20% chance of selecting a penguin or a camel. Number 12 says, what's your estimate for the probability of selecting a rabbit? I don't see a rabbit. So that's an impossible event. Okay. 13, is there the same number of each kind of animal cracker in the jar? Explain your answer. So looking at this data right here, I feel like in that jar, like this sample right here, it's representing the entire jar because remember it was a really big jar, so the kid only just pulled out 20 animals. And just from this sample, I think that there's probably more elephants in the jar than any type of cracker. Okay? So no, I don't think there's the same amount because there seems to be more elephants than any other types of crackers. "14. If the student randomly selects another 20 crackers, would the same results occur? Why or why not?" So remember, these 20 were just selected out of the main jar. So if he went through and selected just another 20, would these results be exactly the same as this data right here? And I'm thinking probably not. Results might be similar, but it'd be unlikely to be exactly the same. And you can put this in your own words too. Make sure this makes sense to you. Oops, I can't spell. Unlikely to be exactly the same. Okay, number 15 is a pretty important one. Make sure you understand this. If you don't, please let me know, okay? Because you're going to be asked to do similar questions in the future. So if there are 500 animal crackers in the jar, remember this is only 20 of this data only represents 20 of them. But if there are 500 in the jar, how many elephants are in the jar? Explain your answer. Okay, so you would want to start off with your sample stuff right here. So in this one right here, in this data, I see there's 5 out of the 20, okay? So I'm going to go ahead and label that. So that's elephants. And that is that's the whole in the sample. Okay. And they're saying, hey, what if there were 500 animals? So they're saying, well, if there were 500 as the whole, how many of them would be elephants? So see right here, we've set up a proportion, and you need to go ahead, kind of like, you know, the like what you would do to find equivalent ratios or equivalent fractions. You figure out what number this is, okay? So to figure this out, I got to go 20 times what number equals 500. Well, I can't really do that in my head to go, I mean, I don't really want to sit here and guess and check, is it 1? Oh, 20 times 1, that's not 500. 20 times 2, is that 500? No. I don't want to sit here and go through all the numbers. So a faster way to do that, if I'm looking for the factor that I multiply by 20 to get 500, I can just divide. 500 divided by 20 gives me 25. So I should know that 20 times 25 gives me 500. If I do that to the denominator to set up the equal fraction to this fraction, I need to also multiply the numerator by 25. 5 multiplied by 25 is 125 elephants. Okay? So basically 1/4 of the jar is elephants, the big jar. And if you're like, how'd she get that? I just simplified the fraction. I went ahead and 125 goes into 125 and 500. So I went 125 divided by 125. Divided by 125. And that would give me 1. And then 500 divided by 125 is 4. Which is 25 hundredths as a decimal, which is 25% as a percentage. So I know that 1/4 of the jar is composed of elephants, because this is how many elephants are in the jar.